Welcome to the second part of the chapter motion. Today we are going to do some numericals based on distance and displacement, and also if possible I'm going to start with the next part, that is speed and velocity. Okay, so the first example over here which you see, they are asking, let us consider the previous example of a person riding on a bicycle. I am sure you remember this example from the last part. Yes, they are talking about this particular example, right? So I'm again going to draw or show you the image on which this particular example is cited. Let's go and check. uh, Person riding on a bicycle. Let us consider an activity from t is equal to 0 to t is equal to 3 seconds. Now as you can see from this particular diagram, at t is equal to 0, the person was at the reference point, then t is equal to 1, t is equal to 2, t is equal to 3. At t is equal to 3, the person was 6 meter away from the reference point, right? The person moved in the right hand direction from the reference point, starting at 0 second, and till 3 seconds we observed the person. He reached at 6 meter away in the right direction from the reference point. So what they are asking now, see, they have not mentioned here. I will mention so that you don't have any confusion, right? So we have to find the distance covered by the person as well as the displacement of the person. The distance covered by the person as well as the displacement of the person from t is equal to 0 till t is equal to 3 seconds. Now look at this. Look at this diagram. So what they are showing over here, the bicyclist moves from point A, that is the reference point, 0 meter, to point B, right? Anything which is to the right side of 0, as you can see in the figure, anything to the right side of 0 is always considered positive. See the positive sign? And anything towards the left side is always considered negative. But left side of what? Of reference point. So reference point is the starting point. Now here in this example, the bicyclist moves from point A to point B, that is towards the right side of the reference point, right? Now tell me one thing. If I ask you this question, what is the total distance? What is the length of the total path covered by the bicycle? Now you will see that in the second figure, you can see that if the bicyclist moves from point A to point B, the length of total path covered by the bicyclist is 6 meter. So what is the length of total path? Length of total path is nothing but distance. So distance is how much? 6 meter. And if I ask you, what is the shortest distance between initial and final points? Now the initial point is point A, right? Final point is point B. If you want to find out the shortest distance between point A and point B, join them with the straight line. They are already joined with a straight line. So what is the length of that particular straight line? That is 6 meters. So what is the displacement? Displacement is the shortest distance between initial and final position, which is also 6 meter. So in this example, distance and displacement both are 6 meter. So you remember that in your distinguish between distance and displacement, there was a point. Uh, I think not in distinguish. There was a point, but it was little twisted. But let me tell you one point, that distance can be greater than or equal to displacement. And in this case, we are looking at the second case, that is equal to. Distance can be greater than displacement, or distance can be equal to displacement, right? So in this particular example, we can see that distance is equal to displacement. Both are 6 meter. The total length of the total path covered by the bicyclist is also 6 meter, and the shortest distance between the 2 points in which between which the bicycle moves is also 6 meter. So this is the example. So they have drawn a conclusion here. Let us understand what is it. When a body moves in a straight line without reversing its direction, then distance is equal to displacement. Then distance is equal to displacement. Please remember that this is the only case where distance is equal to displacement. Now you must be wondering that why have they put these two straight lines? What is the meaning of these two straight lines? See, displacement can be positive, displacement can be positive or can be negative. So to show that displacement is positive, we put the displacement in this kind of between these kind of vertical bars. These vertical bars are also known as modulus or mod in normal terms, right? So that is just to show that displacement is positive. Okay, so when a body moves in a straight line, displacement is without reversing its direction, then displacement is always positive and it is always equal to the distance. Correct? Let us consider the same example, but now the activity is from t is equal to 0 to t is equal to 7 seconds. You remember what the cyclist did from t is equal to 0 to t is equal to 7 seconds? So I will show you the example with the help of a sketch. From t is equal to 0 till t is equal to 7 seconds. A is the final position, A is the initial position and C is the final position. Again, we have to find, they have not mentioned, but we have to find the distance and displacement. Distance and displacement. Okay, now see, the bicyclist is starting from point A. First, we are going to calculate the distance. What is distance? Distance is the length of total path. Length of total path which is traversed by any body. Length of total path which is traveled by any body. ऐसे भी बोल सकता है. So bicycle starts from point A, goes towards the right, towards point B. How many meters? 6 meter. So first we will add 6, right? Plus from point B he turns back and goes in the opposite direction to point C. How many meters? 9 meters. So 6 plus 9 is how much? 15 meters. So this is the distance, length of the total path covered by the body. Displacement. Whenever we talk about displacement, the direction is very, very important. So first, the bicyclist starts from point A and moves towards the positive direction. How many meters? 6 meters. So I will write plus 6. Then he suddenly turns back and goes in the reverse direction, that is the opposite direction, and travels how many meters? 9 meters. So this will be minus 9 meters. So plus 6 minus 9 is minus 3 meter. So the displacement over here of the body is minus 3 meter. If you want to check this, there is another method of checking this. What is the initial position of the body? This one. Let me use green color. This is the initial position. What is the final position? This one, right? Because body goes from A to B to C. So A is the initial position, C is the final position. Where is the final position with respect to the original position? It is towards the left side. And what is the sign of the left side? Negative sign, opposite direction, negative sign. So how far is point C from point A? It is 3 meter far, but if you consider the direction, it is minus 3 meter far. So what is the displacement of the body from point A to point C finally? Minus 3 meter. And that's what we got over here also. So now it should be very, very clear that distance and displacement are not always equal. Because distance, you don't consider direction. You just keep on adding how much the body is traveling. But displacement, you have to consider direction, and then you have to consider the plus and minus sign according to the direction. So distance and displacement are equal only when the body travels in the straight line without reversing its direction. But when the body reverses its direction, displacement can never be equal to distance. It will always be smaller than distance. In this case, it is smaller than distance, right? So I hope this example is clear. Let's go to the next. Okay, there is some one note is here. Let's have a look at it. Displacement can have a negative value in rectilinear motion. What is rectilinear motion? Rectilinear motion is motion in one direction, straight line. And displacement, whenever measured in a straight line, can have a negative value also, right? Because in straight line, there are two directions, forward and backward. So that's why displacement can be positive and can be negative. Okay, there is a misconcept. What is the misconcept? The misconcept is that distance is the magnitude of all displacement in all cases. Means the magnitude of distance and displacement is always the same. That is a misconcept. That is wrong. What is the right thing? The right thing is distance is equal to the magnitude of displacement only when the body moves in a straight line without reversing its direction. Only then distance and displacement are equal. But if whenever the body reverses its direction, then displacement will change. It will become lesser than the distance. Right? Let's look at example number 3. Refer figure number 7. Divya starts her journey on a car from her house and travels a distance of 4 kilometers towards east. Okay, so this is the figure. This is point A, which is Divya's house. This is Priyanka's house, and this is the school. So, what is the question? Divya starts her journey on a car from her house and travels a distance of 4 kilometers towards east, where her friend Priyanka lives. She picks up Priyanka and moves towards the school, which is located at a distance of 4 kilometers towards north with respect to Priyanka's house. The initial point of activity is Divya's house and final point is school. What we have to find? We have to find the distance and displacement. Again, they have not mentioned. I will mention here. You have to find the distance traveled by Divya and displacement of Divya. Okay, so we are doing this question in perspective of Divya, right? Let's look at the question again, the figure again. Okay, the direction I'm just going to mention over here. This is east, west, north, and south. So first Divya travels 4 kilometer east towards Priyanka's house and then picks up Priyanka from her house and travels. They both travel 4 kilometer north, right, and reaches the school. So in this case, the first thing which we have to find is distance. What is distance? Distance is the length of total path covered by a body. So Divya is covering 4 kilometer first and then again 4 kilometer. In which direction does not matter. So the distance traveled by Divya will be 4 plus 4, that is 8 kilometer. Right? 4 plus 4, 8 kilometer. Okay, what is the displacement? Now, displacement, the definition of displacement says that it is the length of the shortest path between initial and final point. Initial point is Divya's house, final point is the school. We have to find the length of this particular line, that is AC. Displacement is equal to AC. We have to find the length of AC. So how do we find the length of AC? Now look at this figure. Does it look like a right angle triangle? So in triangle ABC, angle ABC is equal to 90 degree. Now you might wonder that how come angle ABC have taken as 90? They have not given it. So let me tell you that the angle between any two consecutive direction is always 90 degree, right? The angle between any two consecutive direction like east, south, west, south, these angles are always 90 degree. So angle ABC is 90 degree. So therefore, by Pythagoras theorem, you know Pythagoras theorem, right? By Pythagoras theorem, AC square is equal to AB square plus BC square. What is AC square? We don't know. What is AB square? AB square is 4 square. What is BC square? 4 square. So AC square is equal to 16 plus 16, that is 32. And AC is equal to root of 32, that is root of 16 twos are, that is 4 root 2. If I simplify this, root 32 is 16 into 2 and that is 4 root 2 if 16 comes out of the bracket. And what is the value of root 2? 1.414. So if I multiply this and simplify, so I get 5.656 meters, or you can round it off and write it as 5.66 meters. This is the final answer. So that is the displacement. Now you see the displacement's value is smaller than distance. It is mostly the case. Displacement is always smaller than distance because distance is the length of total path covered and displacement is the shortest distance between initial and final point. Right? So this is how you calculate distance and displacement. This is a very important example. Please remember it, note it down. Okay. One more example they have given. Let a car start from initial position I and move in a semicircular path in clockwise direction and reach final position F, which is diametrically opposite to I. Again, they have not said what to do. So we have to find the distance and displacement. Right? Okay. So car is moving on a semicircular path. They have not given the radius, right? They've not given the value of radius. Okay. So here, can you tell me what is the distance? The distance is the length of actual path covered by the car. That is, if the car starts moving from point I and goes round and goes to point F, the length of this blue highlighted part, length of the blue highlighted part is the distance. So what is the distance in this case? Distance is length of, let me make some space. Distance is the length of semicircular arc. Distance is the length of semicircular arc. Okay. Now what is the length of semicircular arc? Length of semicircular arc is circumference of a circle divided by 2, right? Because it's half circle. The circumference of circle is the length of the boundary of the whole circle. This is just half a circle. That's why I divided by 2. It's a semicircle, right? What is the formula of circumference of a circle? 2 pi r upon 2. So that is pi r. So the distance is pi r. You know the value of pi, right? The value of pi is 22 by 7 or 3.14. So distance is the length of semicircular arc, which is circumference of a circle divided by 2. That is 2 pi r divided by 2, which is pi r. What is the displacement? What is the displacement? Displacement is the shortest distance from initial point to final point. Okay. Now, do you see the initial point over here? This is the initial point and this is the final point. So what is this line which we are seeing here? It is nothing but diameter of the semicircle. Diameter of the semicircle is the displacement. Let me write here. Displacement is equal to diameter of semicircle. Now what is the formula for diameter of semicircle? 2 into radius. The diameter of circle or diameter of semicircle is twice the radius, 2 into radius. So the displacement is 2r. What was the distance? Pi r. What is the displacement? 2r. So if you know the value of radius, you can put the value of radius over here and find the displacement. Okay, so that was one more example for you. Okay, there is one more example which I want to take. Yes, and that comes over here. There is not much. Yes, okay, cool. So I'm going to discuss this example now. This is the first solved example. I'm going to discuss a few more with you. Whichever one I leave for you, that you are going to get as homework. But I'll try to do all the different ones for you and show you how it's done so that you can solve the questions from the uh, homework very easily without any doubts. Right? Great. A circular cycle track has circumference of 314 meter. Okay, so the figure which you see over here is a figure of circular cycle track, which has a circumference of 314 meter. Okay, with AB as one of the diameter. A cyclist travels from A to B along the circular path. So cyclist goes from A to B along the circular path. Okay, with a velocity of constant magnitude 15.7 meter per second. Now you will ask me, sir, what is velocity? You have not taught us. Yes, we are going to learn about velocity in the next part. Velocity is nothing but speed. Speed is measured in meter per second. Now let us see that in this question there is any use of velocity, or they have just given it like that. Find the distance moved by the cyclist and the displacement of the cyclist if AB represents north-south direction with A towards north, this is north, and B towards south. Okay, so there is no need of velocity over here in this question. They have just given us to confuse us, right? First, the circumference is 314 meters. And the cyclist moves along the circular path from A to B only. Okay, A to B only. So what we have to find? The distance. So we just saw that distance is the length of actual path, and since the cyclist is covering a semicircular path, what is the length of semicircular path? Circumference divided by 2. What is the circumference? 314 divided by 2. So how much is 314 divided by 2? So if you divide over here, 314 divided by 2, 15s are 30, 147, 157. You get 157. So the distance covered is 157 meter. Always write the units. Distance covered is 157 meter. What is the displacement? See, displacement from A to B is the length of shortest path, and here the length of shortest path between A to B is nothing but the length of diameter, right? What is the length of diameter? 2 times the radius. Do we know the radius? No. So first we have to find the radius. See how we find the radius. Now 2 pi r is equal to 314, right? So 2 into 22 by 7 into r is equal to 314. So r is equal to 314 into 7 upon 2 into 22, right? Now if you divide 314 by 2, what would you get? We just divided 314 by 2 and we got 157. So 157 into 7 by 22. Is 157 divisible by 22? No, it is not. So we can find the radius, or we can multiply the whole thing and get the length of the diameter. Therefore 2r will be 2 into 157 into 7 upon 22. If this 2 can get cut with 22, it becomes 11. Is 11 divisible? Can 11 divide 157? 11 ones are 11, 4, 47. No, it cannot. So we can simply write it in fraction or convert it into decimals. Let's convert it into decimals. Okay, so when I convert it into decimal, I get 99.09, which is 99.1 meter. Okay, so I will write 2r, that is displacement is 99.1 meter approximately, right? So one second, one more thing we have to write. See, the cyclist is going from A to B. So the displacement is from A to B towards south. You must write the direction in the problems involving displacement only. In further chapter you don't need to mention the direction, but because they have mentioned something about the direction in the question, A is towards north and B is towards south. So you should mention in the answer also that the displacement is from north to south, that is towards south. So this is how you solve it. right? It is clear. Let's check. So they have directly found the value of diameter as 100 meter. Our answer was 99.1. They have directly found it as 100 meter by using the value of pi. So that was a clever thing to do. I did a lot of calculation. So this is a better way of doing it. If you see, this was correct. Displacement is diameter of the circle. We knew 2 pi r. We just had to divide it with pi. So we would have got it very easily, right? But our answer is also correct. It is not wrong. Let's go to one more question. Okay, let's solve this. A woman travels a distance of 1 meter towards north. Okay, first let's draw the directions. Okay, so this is north, south, east, west. A woman travels a distance of 1 meter towards north. So let's say this is the starting position O, 1 meter towards north. Okay, 1 meter. This is point A towards north. Okay, then 2 meter towards east. Okay, and then 2 meter to point B towards east, and finally 3 meter towards south. 3 meter towards south. Okay, maybe this point C. So that is 3 meter towards south. Okay, find the total distance and displacement. Great. Now focus on this question, please. The total distance will be the length of actual path covered by the body. The total length of actual path covered by the body. So 1 plus 2 plus 3, that is 6 meter. But if you want to find the displacement, that is the shortest distance between initial and final point. I'm just going to use another color. So if I draw a straight line, sorry, I will draw a straight line from A to C. Okay, so that's my straight line from A to C. From O to C, I'm sorry. This is the initial position. Initial position. And this is the final position. Final position. So if I draw a straight line, how do I find its length? How do I find the length of OC? For this, I need to draw some, you can say, some constructions. So first, I will draw a parallel line from O parallel to AB to meet BC at one point D. Okay, for displacement, we cannot do it directly. So first we will draw OD parallel to AB. We will draw OD parallel to AB, right? Now ABDO is a rectangle. ABDO is a rectangle because this angle is 90 degree. This is also 90 because first the lady moves from in the north direction, then in east direction. North and east are 90 degree to each other. Then from east she moves south. South and east are 90 degree to each other. So these two angles will be 90, and since OD is parallel to AB, these two angles also will be 90. You don't have to mention all that geometrical part. You can directly write ABDO is a rectangle, and therefore AB is equal to OD is equal to 2 meter. Why AB is equal to OD is equal to 2 meter? Because opposite sides of rectangle are equal. And similarly, OA, you see OA over here is equal to BD, yeah, DB, which is equal to 1 meter. So, see, we know that BD is 1 meter. Okay. Can you tell me how much is CD? Therefore, CD is equal to BC minus BD. BC is the whole thing from here to here. If you subtract BD from BC, you will get CD. So CD is equal to 3 minus 1, which is 2 meter. So we got CD as 2 meter and we got OD as 2 meter. So triangle ODC, in triangle ODC, angle ODC is equal to 90 degree, right? Therefore, by Pythagoras theorem, let me show you. They have just done it directly, no statements, nothing. I have elaborated in a very, very nice way. Okay, so it's good for you. By Pythagoras theorem, I'll continue over here. OC square is equal to OD square plus CD square. So OC square is equal to, OC is the length we need to find, that is the displacement, right? With the green line. So OC square is equal to OD square, which is 2 square plus 2 square. So OC square is equal to 4 plus 4. So OC square is equal to 8, and therefore OC is equal to 2 root 2. We have learned this in chapter 1 of maths, how to take root and simplify. Root 8 is 2 root 2. That is 2 into 1.414. That is 2.828, which is equal to 2.83 meter if you round it off, right? So this is the displacement OC which you have got here. Please note it down. Please note down the steps, the method, understand the method, look at it again once more so it is very, very clear, right? So the total distance is 6 meter and the displacement is 2.2 root 2. They have left it here, but what we have found is exactly 2.83, correct to 2 decimal places, right? So I hope this is clear now. You can find distance and displacement. So practice exercise 1B is beginning now. Before we go over here, I just want to take one more example, one more tiny example. Just imagine that there is a circular path. Hey, can I draw a circle over here? They're saying oval. Okay. Oh, nice. This is a circular path. This is perfect. Okay, cool.